What the heck are we doing with a thermal camera and some heat-seeking servos? Raspberry Pi Pico and a potentiometer? It's time to learn some LabVIEW with the CTI. Haha, let's get into it.
Hey everybody, it has been a long time since I've been with you, giving you another update about the LabVIEW Community Training Initiative and some of the things that are happening with it. And as you saw in that intro video, I've decided to hook up even more things and got really interesting, especially with a 8x8 thermal camera, which is something I wasn't expecting to have so much fun with. But man, once I started putting it all together, I just couldn't stop adding to the system. And that's really the purpose of the LabVIEW Community Training Initiative, is give you a platform that's inexpensive, fun to play with in LabVIEW, and just fun to build stuff. And it's not like you couldn't have done these things before, but this is the community's rallying cry around let's make sure that we're all sharing the same base level content and kind of building from it. And so it's open source, get involved, join us on the Discord, and let's go from there. But before we go any further, let's go ahead and talk a little bit about what we were just seeing a moment ago. So in a bit of an unorthodox twist, I'm going to break out some presentations on you, but it's just because there, as you saw probably in the intro, there's so many things going on. So let's look at a spreadsheet or a PowerPoint and talk about how we're going to use the LabVIEW Community Edition Training Initiative and what we've got. So what you saw connected up, obviously the wires were very busy, but I have indeed the Raspberry Pi Pico over to the left that we've been talking about. If you haven't seen that, go ahead and look at those previous videos. We're going to go ahead and let's see if I can highlight some of these things. We've got a little servo. You saw that in a previous video as well, where I was using pulse width modulation. So I busted out those videos. I actually had to reference them myself to go and remind myself the frequencies and percentages and such. Then, of course, the potentiometer. So in the last video I think I had done is I had used the potentiometer to control the servo. Once again, kind of already starting to combine multiple things to do more. Still doing that one, using an analog input to read that. And the two new components that we haven't covered up to this point are the, let's go ahead and cover this one right here. That's clearly a 2-line LCD display, relatively inexpensive. It's a little bit tricky to actually get working, but the crew over at the LabVIEW CTI and the open source, actually Derek Bomarito predominantly, figured out all of the custom commands that we really need to get this working, not because of LabVIEW, just because it takes a little bit of finagling to get going. And the one that I took off running with myself, along with another gentleman in the community, Steve Watts, was this thing right here. It is an 8x8 thermal camera that we're going to see exactly how it behaves and allows us to create a heat-seeking version of LabVIEW. All right, so just as a reminder, in case this is your first time watching this video, the Raspberry Pi Pico is a microcontroller, not a single board computer. So it has a lot of limited functionality, but it is acting as a peripheral going to the computer. So you attach it to the computer with a USB cord, and it shows like a COM port or a serial port, and we send strings to it and get strings back from it. That's all that we need to do. We are using the CTI firmware. It's not that you couldn't make your own firmware and use LabVIEW to talk to it. It just happens to be the CTI firmware is ready to rock and roll. You drag and drop it onto it when you plug it into your computer, and it's already ready to work, and there's a lot of APIs and functionality built around it. And the big thing that, as I've played with this more and more, I've realized that it is such an enabler to talk to other things that need simple digital protocols. And there's a lot of stuff, especially in the hobbyist community, where you can do that. Like, once again, there's thermocouple sensors, there's hygrometers for moisture in the air, there's GPS sensors, there's LoRa sensors. There's a lot of stuff that's kind of already pre-canned as discrete components that you can find from the likes of DigiKey, Newark, Farnell, Element 14. You know, all of these simple distributors around the world carry these little things that are pretty, once again, under $5 and most all of it. All right, so now we've got the servo. This is one thing that we were working with before in one of those previous videos. It's pretty strong, surprisingly, but it can get you to an absolute position based off of a specific percentage of a pulse width modulated signal. And you can see some of the values right there. It goes basically back and forth. How's that go? 90 degrees? So you get 180 degree swing out of it. And of course, it typically comes with these little horns that you can attach. All right, so moving on, we've got this this LCD. This is the part that we haven't seen up to this point. So this is really, really slick because it gives you this idea that if I'm going to make something, I now have the ability to just give a display to it. And although it's very limited, and this isn't the only one that we can add, but it does give the idea, like if I make a box, I want to know what's going on with that box, or I need to change some capabilities with it. I need to tune some, I want to, as I interact with these buttons, maybe I go through a menuing system. This is the kind of display that enables something like that. Really, really inexpensive and very, very powerful. And so it has, you know, kind of an adjustable backlighting. You adjust a little potentiometer in the back of it. You're going to communicate to it with I2C, so you need both data and clock lines. Of course, there's power and ground, as you can see it there as well. You would use the CTI, once again, wrapped LabVIEW drivers that kind of wrap a bunch of I2C commands, just because, once again, the idea of setting up all of the ins and the outs, and you know, a few people took a lot of time and effort to figure out the manual for this and give a really simplified driver around it. And one of the really slick things that I didn't expect is you can make your own custom characters. When you can see, we kind of have this illustration down here in the bottom where you can, these are just what's a 5x8 grid, and you can go ahead and turn those on and off and upload them to the device, and then you can call those individual characters to the forefront. And when you do that, then all of a sudden you can display all sorts of interesting things that aren't ASCII characters. You can make things look like they're pictures inside of it. It ends up being relatively limiting, but it's also very powerful for certain applications. All right, so this is the coup de grace, as one might say, in terms of just a differentiated experience. It's a little bit more expensive. This talks anywhere from like $20 on Alibaba up to like $45 on Amazon. But this is a thermal camera, or thermal sensor, but it has an 8x8 grid. So you get 8 pixels across, 8 pixels down. And it looks like there's a lot more than 8 pixels down in that image below, but with a little bit of signal processing, and luckily it's built into LabVIEW and it's super easy to use. You can go ahead and transform all of your data very quickly. We communicate to it over I2C, and so in this case, the code that I'm going to show you is really, really raw. But we're also using some, we're just calling it in a raw fashion. I'm not wrapping anything inside of sub-VIs. I'm leaving it all at the surface so that you can see how you would take off communicating with anything of your own. And like I said, you got to read through the manual and figure it out. But usually it's just a couple registers set in the right order. And then once you get the data back, it's just bit twiddling to figure things out from there. There's more things that are capable with this, but we're really not going into all of it. All right, and then of course we've got our potentiometer, which we're going to use for the analog input. Nothing glorious, but really in the sense of completeness of all things hooked up to the Pico, I really wanted to kind of mention that. So what we have, this is kind of a loose diagram minus the power lines hooked up into the Pico in terms of how we're working with it. And so you can see we're using a couple general purpose lines as the I2C communication for both the display and the thermal camera. We've got a pulse width modulated and analog input. Really the only thing missing from this entire implementation, probably to round it all off, would have been to do the buttons on the breadboard that I had, and to maybe change the modes. And that's actually one of these things that maybe, depending on the length of this video, probably already too long, already 8 minutes, thanks for sticking with me, that we can go into deeper to talk about what we would do. Maybe use I like the idea of the buttons to increase or decrease the speed of the scanning that you saw in that intro. So as just a light reminder for anybody seeing this for the first time, and I mentioned the LabVIEW Community Training Initiative, you can go to its website, you can look at that, look in the description below for that information, but really at the core of it, as a big reminder, the Community Training Initiative is the idea of making LabVIEW available to anyone, anywhere. So how do we do that? Well, it needs to be basically free, right? Usually the limitation for anything is a network connection and money. And so if we have a network connection and a computer for someone, and we have ways even to make that less expensive, we're trying to dive down into that. And so what does that mean? Let's go ahead and do that recap on the CTI. If you don't want to go through this, find the chapter marks, we can hop over it. But at the core of it, it really starts off with this virtual machine. If you don't want to get your computer all set up and configured and download LabVIEW and all these things, and you kind of want to get going fast, we have a virtual machine that goes into VirtualBox, which is a free piece of software. The virtual machine is free to download. It's you can run it on Linux, so it's Linux compatible. So if you've got that, you can use that. And LabVIEW Community Edition is already loaded on it, and that is a huge advantage. So if you are like, I don't know how to get started, what do I download, what do I do? Download the virtual machine if you want to start there, and you're already up and running. And then also, even if you didn't have some of the hardware that you saw here, the $5 Raspberry Pi Pico, maybe it's not available in your area, there's a simulator that will go ahead and show you, hey, I'm sending commands down to what should be there in terms of hardware, and you can see the response and how that's working. Obviously, you're not going to see the entire rat's nest that I had in front of me of various electrical cables, but you will get that idea that I'm using LabVIEW, I'm turning Boolean things on and off, I'm pulse width modulating, and on and on. So the other part of the overall system, once again in terms of CTI, if you're going to be able to pay for it, is the Raspberry Pi 2040. And the 2040, and a microcontroller is basically dumb when you get it. It doesn't really do much of anything. But the crew, actually mostly once again, an individual taking care of the CTI did a ton of work to make a really elegant firmware loadout for the CTI that goes on the system. And so that is how you would load onto it, and all of a sudden you now have this device that kind of acts like an instrument, and that's such kind of the natural way to express LabVIEW if you're going to be an engineer using it to control instrumentation. And so we're going to talk to it and do that in the same way. And I already mentioned a lot of those accessories, other than that thermal camera, are exceedingly inexpensive. And then the other part of what the CTI is the open source training material as well. Like LabVIEW Core 1, 2, 3, any of the NI or any NI training material is not free to use. If you have a copy of it, you can't just go out and start teaching it. And if you wanted to take it and modify it and start teaching it yourself, that's not allowed. That's not part of the license. That's not what NI and now Emerson, overseeing all of this NI material, permits. And so the community said, well, let's start something open source that is free to use, free to modify. And it's not anywhere near as complete as what has been existing for the NI ecosystem for a long time, but that's okay. It's the start, and now it's, we're all learning what's needed inside of it. How can we use this hardware platform to mate up with training material to give the richest experience so that you can feel that power of what LabVIEW is capable of. So speaking of the training modules, you can see if you go to the website and you click on that section that you can see over to the right-hand side of the page, you'll see that there's, lesson 1, 2, 3, 4, 5, and there's some other ones that are in work. So that's still, as you can see, sections are under construction. There is material in there. Some of it needs updating with the different firmware, but it's available. And there's an entire process in GitHub and kind of a CI/CD workflow for, hey, if there's an error, if there's an update, or you want to extend it and contribute back to the community, get into it, find us on the Discord, and you'll be able to start contributing to that material. So for the moment, it kind of needs an instructor to guide one through. And so this is intended to be material that helps an instructor do the instruction rather than just something that you take off running. But if you know somebody, if you're learning, if you want to go through this and start, then let the community be your instructor and then kind of go through that. And ideally what I can do is take some of these videos and your time, I appreciate it once again, to go ahead and create that content as well. So if we were to kind of pull it all together, what happens when you connect into this? You start off with drivers, once again, you can look to some of those first videos that we did, and you can see that there's some LabVIEW drivers. It's installed, you put it in the right directory. You call those drivers, and underneath the hood, it's using Visa and serial commands to talk to that Raspberry Pi Pico over USB. The firmware on it is C++ code that has been once again supplied from the Community Training Initiative, and the information that goes back and forth are these Skippy formatted strings. And if you're curious about what those commands are, you can open up a tool called IOTrace on Windows, and let's see what that looks like. So if I go here and go IOTrace, you can go ahead and open that up. And so now IOTrace is open. Now this is a great debugging tool, once again, to see those Skippy commands. You can hit the start button. And if I were to go ahead and leave this off to the side of the screen here, and then I'm going to go ahead and open up my thermal camera. And so although the screen is very compressed and compact at the moment, you can see that I'm sending a bunch of VISA reads and writes back and forth to my device over COM9 and getting all the information from my thermal camera as it's sweeping and scanning and pulse width modulating the servo on and on and on. Now, although there's a lot of data here, it's a great debug tool, and we're going to go ahead and look at that in a different video, not right now. All right, so let's take some time to tease apart some of these things that we haven't talked about before. We're going to talk about the LCD display and then also that thermal camera. So let's look into what those very first steps are for you to leverage a simple device just like that. So let's go ahead and turn that down. And one thing that I really want to highlight here is that the CTI drivers Visa, that is the GitHub repository that's going to kind of get you the latest and greatest things that the community has been working on. So you can download that from Git, you can see the branches that are available. But the directory that is kind of like your playground of certain things is going to be this CTI scratchpad, and you can see it's actually a library there that you can go ahead and open. And of course, this is going to be your key project that you can open in LabVIEW to kind of do things. And so the reason I wanted to direct you to this is because this is how I learned how to go and control something like the I2C. So if I wanted to go through and do I2C LCD hello, I'm going to go ahead and open that up. I'm going to point it at my specific COM port, and then I'm going to go to the block diagram and see if I need to modify anything. Now, on this one in particular, you can see that it is using a unique type of LCD. And also, we're using the API has changed a little bit, possibly since you saw it last, because we've taken the efforts to go through and make it more robust so you can do two things at once, read from an ADC and control the display, for instance. And so the way that you do that, if you're working with a specific peripheral, is you take that session that you're working with, that is kind of your common session for all things connected to your Raspberry Pi Pico, and then you would kickstart a new session specific for your end device. Now in this case, it is showing as the Grove LCD. That is a different LCD than the one that I've got. And so what I'm going to go through, and actually I'm going to double click on that individual device. I'm going to press Control-Shift-E. It will take me to that location in the project where that is. And you can see that it's located underneath the peripherals library. Now, I could have gone on disk and found all this, but if I've already got an example that takes me most of the way there, let's go ahead and do that. It's just faster. And you can see that there's my LCD that exists right there. So probably actually what I need to do is just replace that one function, the initialize function, for the init for that specific one. And I think it's actually like PCF, so I can probably actually just use a quick drop and then replace. Let's go ahead and see what happens when I get in on it there. And I can do init, PFC, PCF, and right there. So you can see that I've got init as my very specific function that's available. I can press Control-P to replace it on disk. And what you'll notice is that those functions that we had just a moment ago have now changed. By using the polymorphic nature of the classes and sessions that we have available in LabVIEW, everything downstream automatically adapted to find the right function. And so that's what we do here, because they're all part of the same class or same library. So that we've got that has changed over. I can go ahead and modify another thing on here. I need to modify the pins that my specific device is going to. And so it's powered up, but I know that if I look over here, I can probably figure it out. It's going to pins 6 and 7, and that is my location that I need to be in for changing my clock and data. That looks like it needs an address, and that's one of these things associated with these simpler LCD displays, is that they do have unique addresses associated with them. So let's go ahead and run that one time and see what we get. All right, so I ran into one other problem. I said to change the pins associated with that device, but also there's two I2C buses on the Raspberry Pi Pico. You've got to change those as well. So it's just getting used to using a new piece of hardware. Once again, as we dive into using anything in LabVIEW, you're learning how to interact with the language, but then also the driver behavior of something that you're connecting into, well, typically at least. And so now we've gone through, we've changed over the initialization to have it be the right device. we've gone into modifying it to the right I2C bus and the pins associated with that I2C bus. And if you want to know more about that one, let's go ahead and see where that exists. Now for me, the way that I do it is I normally search for the RP2040 pinout, and then I start looking around at those individual images. Let's go. And you can see here's the basic layout for this Raspberry Pi 2040. And one of the things, if I get in here just quite about right, you can see that there's it's pins 9 and 10, but it's general purpose 6 and 7, and it has the I2C1 bus. If you had connected two pins 1 and 2, or general purpose 0 and 1, I would have had to change that to I2C 0. So as you're working with this one, it gets me caught up frequently. Don't forget, you've got to identify which specific bus it is, because everywhere that you see those blue boxes on the screen here is an illustration of another place that you could connect to an I2C bus, but you only have 2 of those I2C available. But let's go ahead and keep that one handy just in case. All right, so hopefully that gave you the feel of how easy it can be to just go ahead and connect into and just send some information, just populate the display. But one of the things about this little display is it's pretty dumb. You send characters to it, but you are in control of everything. So if you want to write something new, you have to clear out the old characters because it'll just keep displaying them. If you wanted to draw something at a specific location, you have to move the cursor somewhere else. And there's a lot of discrete features that I'm still getting used to in it, but it is necessary to go ahead and do things like clear the device. And let's go ahead and dive into the more detailed version of this. Once again, all within that specific directory where we were looking on just a moment ago. That is the Scratchpad directory. And if I look underneath the I2C LCD, there should be a full. There we go. There's the full. That's going to give us the ability to get really, really clever with a lot of different things. So once we've got that there, let's go ahead and reproduce all the things that I needed to do to get stuff working. Pointed at COM9, I2C1, and the data is 7 and the clock is 6. And I should be able to, oh, look, the example that we have here already takes advantage of modifying which specific target you're going to. Very helpful on that one. And I'm going to go ahead and move it to address 27. But I'm going to go ahead and move this camera around. Let's see what we can get here. All right, so we are indeed showing display hello LabVIEW, and I can go through and delete that from the system, and I can write the text again, and you should see it still says the same thing, but not quite. Part of what we're looking at is that it leaves the cursor wherever that is done writing. So let's go ahead and write that text again. And you'll see that it just keeps appending to the end of it. And so that's kind of a bit unexpected. Actually, I had even forgotten about it. And so there's the idea of when you're writing to it, you need to clear it, and then you can go ahead and write the text again if you know that that's part of what you would need. There's pros and there's cons. You can see that there is a cursor. We've turned it on and now it's blinking as well. I think we could even turn there's the black light off and black light on. Maybe just the whole display on and off. Probably turn that blinking cursor off. There we go. So we've got a couple different things available. What happens when we turn the cursor off right there? Turn that blink on and off. There's our cursor. It shows it just underneath there. And so the other part is that we can go to very specific rows. We can go to row 2, actually I think it's 0 index, so row 1, and then column 5, and I could write hello right there. Oh, we didn't do the goto. Goto is a very specific command as well, and then you can see I can write that character on it as well. And so that's where a lot of these things happen. And let's see if I can just go ahead and add some of these characters on here. I'm going to make a custom character. Let's make it a little bit of maybe an S symbol of some sort. There we go. So let's go ahead and I created that. So now I've uploaded that to it. I can move to row 1, column 0. I can go to there. And now I should be able to write that text if I modify it to be the /00. And so you can see that we have all of those individual characters up underneath there that have been custom, have been uploaded. And then of course, I think if you just go home and you can start writing those same characters again if we really wanted to, or just clear the whole text and go all over again. All right, so that gives you a good feel for, once again, controlling the display that we were seeing just a moment ago. All right, so now how do we go through and do the I2C commands? Well, you're going to have to wait for part 2 of this one. We're going to dive into that then. This is more than long enough. Thank you for sticking with me. Let's go ahead and keep having fun playing with LabVIEW and getting out there, being part of this community and the community training initiative. And I'll see you in the next videos. Thanks.